So one of the things that makes the Wittig reaction such a great synthetic tool, one of the reasons that it won the Nobel Prize, is that we do get stereoselectivity in this reaction. I can make alkenes that are specifically Z, or I can make alkenes that are specifically E in my reactions. And when we look at those differences, we're going to look at whether our phosphonium ylide has any additional resonance stabilization because of the group that's bonded to the carbon. So in this first example, this is going to be an unstabilized ylide, and this unstabilized ylide is going to occur when my carbon in the phosphonium ylide just has alkyl groups, like what you see here. So that in the resonance stabilization of this ylide, this negative charge at the carbon doesn't have any additional stabilization. And so the products that this type of ylide is going to make is going to be specifically where I get a Z alkene out of the reaction. If, on the other hand, my phosphonium ylide has a group that has something like a carbonyl, where I have additional stabilization when I have that electron density on the carbon, this gives rise to an E alkene in my product. So this is called a stabilized ylide, and it gives rise to an E alkene. And for these stabilized ylides, the carbon is going to have additional resonance. The carbon is going to have additional resonance due to the presence of that carbonyl. So I want you to take a moment and predict the products of the two reactions that you see here. We have benzaldehyde as our starting material in both reactions, and in the first case I have my unstabilized ylide, and in my second case I have my stabilized ylide. Be very careful. Make sure you count your carbons. Make sure you figure out where the bonds are going to be made and where the bonds are going to be broken. Separate your double bonds into the 4 components and figure out how those components will change partners during the course of the reaction. Pause the video and predict the product of these two reactions. So that as you predict the product of these two reactions, these are the products that you should get. In the first example where we have the unstabilized ylide, we should get the Z alkene. In the second product where we have the stabilized ylide, we should get the E alkene. And when we look at the details of the formation, in the first example, this part of our double bond is going to be in one part of our product. Remember that that forms the new double bond with the carbon-containing portion of my Wittig reagent. This forms the double bond with the carbon-containing portion of my Wittig reagent. In benzaldehyde, I have this carbon, which I'll call carbon A, that's bonded to a benzene ring. That's this carbon right here. In my product, I have 4 carbons in my Wittig reagent, 1, 2, 3, 4, which are these 4 carbons in my product. Remember, I also make triphenylphosphine oxide, where my phosphorus and my oxygen also have a double bond. So an additional product that I would get out of the reaction is this one. But you don't have to show that product when you're asked to predict products. So overall, this product here is my Z alkene, where my priority groups are on the same side in that structure. So in the second example, again, I'm going to split my components across the double bond so I understand where the 4 pieces that I'm going to be working with are. Just as in the first example, in benzaldehyde, my benzene ring and that carbon of the aldehyde, that becomes one portion of my molecule. And that's going to be reacting with the carbon-containing portion of my Wittig reagent. So that looks like this. And in my product, here are the carbons that come from that Wittig reagent. And here are the carbons that come from my aldehyde. This is carbon A. This is carbon A. This is carbon 1. This is carbon 2. This is carbon 1. That is carbon 2. So that all of my carbons have been accounted for. Remember, I do also form triphenylphosphine oxide. And just as I said before, you don't need to show that product. And my alkene is an E-alkene, where my highest priority groups at each carbon of the alkene are on efferent sides. So here are 3 synthesis examples that you should be able to do based on all of the reactions that we've talked about so far. I want you to work through these synthesis examples on your own,